Welcome to section 4.3, Applications of Linear Systems. So we're going to do more systems of equations. Specifically, we're going to talk about applications. Well, what are application problems? Many of you know what application problems are. They are word problems. Now, the irony of that is, have you ever asked the question, when am I ever going to need to know this? And then have you also then turned around and complained about word problems? Most real-world applications are word problems. That is what makes them challenging. Now, I get that many teachers do not properly teach you word problems, and this is why they're scary. The other reason is that word problems are difficult to set up. And the reason there is that difficulty is because, well, there's no one way to set them up. They're also difficult because it requires us to remember to use units. If I say the answer is 5 to some problem, what do I mean by 5? 5 feet, 5 miles, $5, 5 people. Even if we're just talking time, 5 seconds versus 5 hours is very different. 5 inches versus 5 miles, again, very different. 5 pounds versus 5 tons. So we need to be very specific about what we use for our units. And in fact, I'll tell you this little trick, or not trick, the truth that units are often the basis as to when you're setting up higher level application problems, or models as they're often called. It's the way we check. So let's just get to a general strategy to help you through this process, okay? I realize this is a general strategy, it does not fit everything, but it's to help you think your way through it. And as a result, it's not going to work. It's not going to be a do this in this situation, because that will never work when you're doing applications. I can always create a new problem that's different. So the first strategy I have for all of you is breathe. And that may seem like a joke. What I'm literally saying is I want you to stay calm and to believe that you can. Take a breath and then approach it. If you start feeling anxious, you're not going to do well. Your brain's going to seize up and you're going to have struggles with a lot of these things. All right, now the first real step of the strategy. You need to ask yourself, what am I looking for? So what does the question want me to find? These are often our variables. So I would label them as such. I would give them some name. And again, I will demonstrate that. After you know what you're looking for, ask yourself, what do you know? So what is the other information that is given to me? I would recommend drawing a picture, making a table, doing something to collect the information in a clear and concise way that helps you with the next part, which is, how do these first two things relate? Because how they relate is how we set up equations or formulas. So if you don't know what am I looking for, then it doesn't matter anything else. Like if I don't know where I want to drive, who cares where I'm at right now or what path I take? Because if I don't know where I'm going, it doesn't matter. If you know where you're going, the next thing you need to know is, where am I currently at? Then you can think about how to get there. So for instance, if you are currently in Gorham and you know you want to go to Portland, you can think about what are the different routes to get there. The same thing as equations are often a part about this. And as I say that, please realize there is no magic formula for this. So you're going to have to create an equation, and you have to think about, does this equation really represent how these things interrelate? Now, after you have the equation or equations, you can solve. And this is the part often actually that people are less worried about. They're more worried about step number 3. That's the big area, because if you don't set it up right, solving is not going to matter. And then after you solve, though, you're not done, because you really need to ask yourself the question, does my answer make sense? And also check. What I mean by does my answer make sense? So think for a moment. If you're talking about time, what kind of numbers are not going to make sense if you're solving for time? Hopefully you're thinking negative time, because as far as I know, unless you have a flux capacitor, you're not going to get negative time. So you need to always ask, does this even make any sense? And if it doesn't, then you probably made a mistake. So go back and ask yourself, did I make a mistake in my solving process, or did I make a mistake when I set up my equations in the first place? So it's not just checking your answer in the equations, but going back to the original problem and saying, does that make sense? Just another example though, if I'm talking about the speed of an airplane, does 30 miles an hour, 30 miles per hour make sense for speed of an airplane? Probably not. Does 1,000 miles per hour make sense for an airplane? Again, probably not. So this is why we use that last thing a lot. Okay, let's just do some examples because that's probably what you're dying for. Again, these are examples. They're not going to cover every possible thing because I'd have to do 5 billion and still wouldn't cover everything. So these are some general examples to get you to help to do this section. Now this section, by the way, is talking about applications of systems of equations. So our equations are all going to be lines, and you're going to have two of them. You have two unknowns. So you get some things for free. Remember, the final exam is cumulative, so that won't be necessarily straight up given. So you got to ask yourself all of those steps. Let's look at this first one. Larry Bird, he scored 12 times during a basketball game. We're assuming no free throws. Some of his baskets are 2-point field goals, and some are 3-point field goals. Scored a total of 28 points. How many of each type of field goal did he score? Okay, so you got all that information. So again, let's go back to the previous steps. Step 0, breathe. Now ask yourself, what am I looking for? Okay, I want you to write down on whatever paper you have in front of you, what are you looking for? And I want you to give them some kind of variable name. Now hopefully, I went with X is the number of 2-pointers and Y is equal to the number of 3-pointers. It does not really matter. You could have used, I don't know, Z and K, or I could have used some other symbol that I wanted to cook up to represent each of them. Does not really matter. These are just placeholders to help us figure out the question of how many 2-pointers and how many 3-pointers. So now we have that in place. Again, if you have something else, it's okay. Just kind of replace whatever you put instead of X, use a different value and so forth. Now I want you to write down what is the other information that you know. Okay, hopefully, and if you didn't, go ahead and pause and finish doing that. Hopefully you wrote down that he made 12 baskets, 12 total points. So notice I already came up with one equation on that, x plus y equals 12. Well, where did that come from? I'm trying to give you this one. Where does that one come from? Well, think about it. Total baskets is 12. Well, doesn't total mean I have to add up how many of each basket? Well, that gives that one. What about the other equation though? So we have two unknowns. We need at least one other equation. How can I use the total points with my x and y to come up to 28? Pause and kind of try to figure something out. Okay, hopefully you thought about it and said, okay, well, each 2-pointer is worth 2 points. So if I score 3 2-pointers, I made how many points? 6. How'd you do that? We did 2 times 3. So isn't the number of points he gets from 2-pointers 2 times x, the number of points from 3-pointers 3 times y, so you get 2x plus 3y equals 28. Now notice we now have a system of equations that we can solve. I want you to pause the video and I want you to solve that system of equations. Welcome back. We're going to solve that system. Now I'm going to personally choose to do elimination in this process, but you can do whatever you want. So I multiply the first equation by -2, which gave me -2x minus 2y minus 24, and then I add that to the other equation to get myself to y equals 4. Well, if y equals 4, you can substitute, plug it back into, why not the first equation, and so you get x plus 4 equals 12, so x equals 8. But wait, you're not done. You really need to restate what is the answer to this thing. So think about that. X, what was x in the first place? I wrote it down. X is the number of 2-pointers. So how many 2-pointers did I score? 8 2-pointers. How many 3-pointers? 4. I should say Larry Bird, not myself. So the answer to that is he made 8 2-point field goals and 4 3-point field goals. So notice this is if you don't just say the answer is 8 and 4 because that doesn't mean a whole lot. Besides which, when you say just 8 and 4, you didn't tell me which one's which makes it really confusing. So take a moment and write. You all are capable of doing that. So just write down briefly what these things are. So let's go on to the next example. It's a piggy bank example. I have dimes and quarters. There are a total of 75 coins in the bank, the value of $14.25. How many of each type of coin are there in the piggy bank? All right, I want you to pause, and I want you to go through the same process. I want you to determine what do I know, what am I looking for, and how do they relate. So I want you to come up with some equations, some variables, and write down all that information. Don't, before you solve, unpause, and let's just check where you're at. Welcome back. Hopefully you had that all set up. So I notice that the things you're looking for are the types of coins. So number of dimes, number of quarters. Well, because dime starts with D, I decided to do D for dimes and Q for quarters. You could have used X and Y. It is perfectly okay. For some reason, you guys are fixated with that. Use whatever letter you want. And be willing to be flexible because, to be honest, more real-world problems are given not in X and Y. They're given in other stuff. Now, what's the other information I'm given, and what are the equations you have? Hopefully, you're like there's a total of 75 coins, a total of 1425, and then we can combine all that. Well, total coins. Can you put the total coins? The equation you can come up with for that one is X or D plus Q equals 75. And then for the other one, I asked myself, how much is each dime worth? Well, it's worth 10 cents or $0.1. And quarters are worth $0.25. That's why I used instead of 25 cents. And it's because this thing is in dollars. So you have to be careful, again, units. If I want to make these cents, I got to change this to cents as well. So kind of be aware, this is where units are going to start playing a bit of a role. Now you have a system of equations. I want you to pause the video and solve the system of equations. Welcome back. This system of equations, again, I decided to do elimination. You could have done substitutions, perfectly fine. I did elimination, so I multiply the first one by negative 10. The reason for that is that's going to give me negative d as my first term. You can check my multiplication. I know it works out. But notice when I add that to the second one, negative d and d are going to cancel each other out. So we're going to get negative 1.5q and negative 67.5 divide q equals 45. Again, we're not done because I need to find a lot more. How do you find d? Well, we substitute back in. D plus 45 75, so d equals 30. And again, you're not done because remember you have to write your final answer. So there's 30 dimes, because D was 30, 45 quarters. This is a nice part of using D and Q rather than X and Y. Because if it's X and Y, you're probably referring back saying which one's which. So be aware, this is why it's nice to use different variables. And then write your final answer. Okay, let's do a third example. This time I'm going to deal with a car and miles per gallon. So I will again want you to pause the video. I want you to write down what am I looking for, create some variables, what do I know, kind of organize the information, and then try to create some kind of equations out of all that. Go ahead. Welcome back. Hopefully what I came up with is I came with C for city gallons and H for highway gallons because we're looking for gallons of gas that are used. So I have my C and my H. Again, you could have used X and Y. You can use, I don't care, as long as they're variables. And what else do I know? Well, I know that I have 25 miles per gallon in city, 15 miles per gallon city, 21 miles per gallon highway, 25 total gallons, and 447 total miles. Well, we can use the total gallons, probably the easy one to come up with. But you're also going to need to use this information. Miles per gallon times gallons is equal to miles. So, in fact, many of you find out what's your average miles per gallon by figuring out how many miles did I take and divide that by the number of gallons. But if I go 10 miles per gallon, I know, horrible gas consumption rate. If I go 10 miles per gallon and I have 10 gallons, I'm going to go 100 miles before I run out of gas, notwithstanding fumes and all sorts of other stuff like that. So, but we can put this together and we get the two equations, C plus H equals 25. So that's the total gallons that many of you probably put together. But this one is, notice, so this is miles per gallon times the number of city gallons. So this is actually the number of miles that are city miles. This is the number of highway miles. And so you total that up to get the total number of miles. All right, pause the video, solve that system of equations. Welcome back. This time when we solve the system of equations, I decided I wanted to go with substitution. So the first thing is I took this first equation and I solved for C. So I subtracted X. If I do that, I can substitute that in for C in the second one. And notice I plug it in, I distribute, I combine like terms, and then I also subtracted the 375. And then divide by 6, so H equals 12. We're not done because remember I got to find C, so I plug that in. I get C equals 13. And so your final answer is you use 12 gallons per city. And that's actually wrong. I wrote down the wrong thing. See, I typed it up wrong and I made a mistake. So what is the correct answer? Hopefully you're saying it's 13 miles for the city and 12 for the highway. So again, that's 13 for city and 12 for the highway. All right, let's move on to our final example, an airplane. So again, I want you to pause the video and I want you to set it up. So write down, what am I looking for? What do I know? And then try to create an equations based on that information. Well, welcome back. The things you're looking for, the airplane speed and the wind speed. So I came up with A and W. I know, extremely creative. I also know a couple things. Now to organize it though, I decided to make a little chart. So with the wind, I have rate, distance, and time. So I'm trying to figure this out. We put brackets around it. Notice then I get this. 960 is my distance with the wind because it's with the tailwind. It's the same distance. This is a return trip. 960. And the question often is, where did I come with a 3.2? I'll show you that in a second. The other one is 960 and 4. Well, that 3.2, here's how I came up with it. I said that 12 minutes, I converted that to hours. Remember, there's 60 minutes in an hour, so I just took 12 and divided by 60. So that's equal to 1/5 of an hour, or 0.2 hours. I did both the fraction and decimal because not everything's going to come out as a nice decimal. For instance, if it was 1/3 of an hour, you got to deal with that. If it's 1/6 of an hour, so be aware that you may have something as a fraction rather than as a decimal. That's okay. You guys can deal with fractions. Now notice I have something missing as I deal with this, and that is the rate. Well, how does wind, if you have the wind at your back, how does that affect your normal speed? Hopefully you're saying it makes you go faster. How much faster? Well, it depends on the wind speed, as well as some aerodynamic information we're not going to get to. Without getting too technical, we could say that with the wind, we're adding in the wind speed to our normal speed. And against the wind is obviously slowing us down. By how much? Well, I can say that A plus W, so with the wind is helping me, and A minus W is here. Now I also wrote this right below here. R equals distance over time. So rate is equals distance over time. This is a very powerful and useful thing that's going to come up multiple times in this class. So rate is equal to distance over time. Well, notice I have rate, I have distance, and I have time. So could you just put all of this together into this equation? Could you put the bottom one into a similar equation. Okay, go ahead and do that. Hopefully, when you did it, notice you got them 960 over 3.2 and 960 over 4. I can further say, okay, I am going to reduce those. If you divide, you get 300 and 240 as your numbers. But now look at them. This is again elimination because it isn't already set up very nicely that the W's are going to cancel out when I do elimination. So you end up with 2A is equal to 540. So A equals 270. Well, we got A, so let's find W. Subtract 270 on both sides, W is equal to 30. But again, what does that mean? Well, that means that my plane speed is 270 miles per hour, and my wind speed is 30 miles per hour. So we can work through this slowly but surely. That's only 4 different examples. We covered a lot of different options. Notice each one was just asking how to help set it up. If you want to draw pictures or do tables, I highly recommend it. Make sure that you're thinking about what equations, and then once you have the equation, you still have to use the system of equations to solve. But you get a pick. You can do elimination or substitution, your choice. Good luck. Please let me know what questions you have.